Oh, whoa. All right, this is the first orange sticker problem. It says a windlass is used to tow a boat to a dock. Do we know what a windlass is? No. Do we need to? No. Okay, the windlass is used to tow a boat to a dock. The rope is attached to the boat at a point 15 feet below the level of the windlass. So from the diagram, which is nice because it gives us one, we say this is the windlass. The rope is attached to the boat. This point right here is 15 feet, as we can see over here, from the top of the windlass. If the windlass pulls in the rope at a rate of 30 feet per minute, so windlass pulls in rope at a rate, oh, it got fuzzy for a second, rate of 30 feet per minute. Well, I know that's going to be a derivative, and I'm thinking it's not going to be this derivative of the 15 feet because the derivative of a constant is going to be 0. Pulls in the rope. So what is changing here? The amount of rope that's out. So as you pull in the boat, closer, there's going to be less rope. So this z distance is changing. That amount of rope is changing at a rate of 30 feet per minute. If the windlass, at what rate is the boat approaching the dock when there is 25 feet of rope out? Again, this z is talking about how much rope is out. So our question is something when z equals 25 feet. Now we need to figure out what is rate at which a boat approaching the dock. What's not drawn in your diagram is that the windlass is on the dock and the windlass pulls the boat towards the dock. So what's going to give us this x right here is sort of going to give us the position of the boat, and the derivative of a position function gives us velocity, which is kind of talking about speed. And really the question is asking us at what speed is the boat approaching the dock. So what we want is dx dt when z equals 25. And hopefully you see the geometric shape that you know lots of information about and can set up your problem next, because they've even given you that right angle already. So we have 15 squared plus x squared equals z squared. 15 is a constant when we take the derivative. 2x times this distance right here is changing as we pull more and more rope in. The boat is now going to be here, and then here, and then here. So this x distance is getting smaller when time changes, so dx dt. 2z times, well, the amount of rope is also getting smaller as time changes. So times dz dt. And now thankfully, we know dz dt equals 30. We know that z of t is 25. That's what we want. Do we have x? No, but we can find what is x when z equals 25. What is the position of the boat? How far away is that distance here when there's only 25 feet out of rope? So that your height of your windlass is still going to be 15. This is now going to be 25. And what we want is what is x here. You can set up the Pythagorean theorem. X squared plus 15 squared plus 25 squared. Figure out what x is, plug it in, and continue from there. Don't forget your units and your sentence at the end.